Hello and welcome to the African Stack, where we are having conversations with the people shaping Africa's digital future. My name is Wawuda, and today we are joined by Mohammad, who is a software and AI engineer at DataWise Africa. Mohammad, thank you for joining us today. Before we start, maybe just give us a bit of an introduction to yourself. What's your background in, and what are you doing right now?
Okay, hi everyone. I'm happy to be here with you, Awuda, today. Okay, my name is Mohammad Kalib. I work at DataWise Africa as a software engineer. In DataWise Africa, I handle more of AI engineering. We are doing several products on AI engineering, developing softwares, internal products, and also external products. Yeah.
Okay. And what's your background in?
Background in tech.
Tech, just
Uh-huh.
everything tech related or
Oh,
anything
tech
specific?
related. Okay, to just generalize it, I do full stack development with AI engineering too, as I said. Full stack development is I do the front end, I do the back end, connect them, and then maybe make systems smarter by integrating artificial intelligence in them.
Okay.
Yeah.
So you say that from what I've seen that you build systems that businesses rely on and that, can be related to what they do. What does that sort of look like in your day-to-day life?
It's kind of a passion to me because let's say the thing that drives me is the feeling that I build softwares and tools that people can rely on and use, which is so important to me to see something that you built, a solution to something, helping other people solve their problems. Because most of these software now, they're just not website to just advertise something. Some of them are really important and they help people out there in, let's say, areas like research, a lot of areas in hospitals building systems that can have like this sort of data storage capabilities and all that type of stuff. Yeah.
So you've mentioned research.
Mm-hmm.
How does research, and I believe DataWise is
Mm-hmm.
a data and research
Yeah,
company.
yeah,
So
sure.
how does research and like AI engineering, how do those two work together?
Okay, I may put it like this. Yeah. Um, Nowadays, there's a lot of research going on, and it's really, really difficult for person. Let's say, let me give an example of maybe like a law field because I'm working on such a platform. When lawyers want to do their research, it's going to be a lot of work for them to read books, check a lot of Excel sheets, check all the cases that have been drafted, and browse website and all that. So if proper research is done, and then there's like a whole compile information, it will take maybe months for someone to read all this information to get answers to something or arrive at some sort of conclusion in their type of research. So if we get this research data and then we put it into a system, it's going to take seconds or even less for them to actually get this type of information, because all the references, all the information that someone may want in to get a system or to get in a certain sort of information, like maybe a lawyer wants to draft a case, check some sort of templates and all that, they can just go into the system and just do a little bit of queries there, and then they get all the answers that they want, instead of taking a lot of days and months reading books and all that type of documents.
So you're saying that you use AI in this legal platform to help lawyers with their research.
Yeah. That is absolutely true. Yeah.
Why do you feel, or like as you were building this system, why did you feel that AI was the best suited to fix this issue of legal research? Why wouldn't you have chosen a different kind of system to solve the issue?
Okay, this is because in this era of AI, we can take a large language model, basically the whole AI concept, and AI is really fast at drafting conclusion, drafting researches based on the information that you hand it. You can give a system. For example, you're having in the system, maybe for example, if I use this example, in the system that you're building, Sheria Africa platform, you can find that we're having um, two major filters. Like we can have two major features. We can have the search and filter, whereby you just put on some filters, and then you get the information. Then now you have the chatbot. The type of information that this search and filter feature can give you, and the other type of information that the chatbot can give you is very different, because now with AI, it can draft the information and also try its best to explain that information to you, get to summaries, get all the citations, and it can really summarize things, and it can make things even faster, because now you have to read these pages. Maybe you're going to a website, you have to read the whole page, but then now in this type of scenario where you're using AI can do that for you, and it can do it in seconds and give you a very good summary in a very shortened form that you can read and actually understand what is going on. Yeah.
So you mentioned
Mhm.
speed, like how fast it does things.
Yeah.
And I don't know if this just applies to AI models that that use different languages, or if it's just all around. But there's
Mhm.
this I've been reading,
Uh-huh.
and there's like the ways in which when AI is, let's say, translating from Kiswahili, or like using Kiswahili as the main language, it has to go to a different server, through translate to English, then come back and translate it back to Kiswahili to be able to give someone an answer. And that takes maybe around 7 seconds.
So, like, you mean a large language model will go to what server exactly to pick the language? Because now you see, if you're talking about large language model, this is something that is pre-trained before I even fine-tune it to my system. It's like it's like this. There's already data in it, including several languages that maybe are trained to it for it to understand. It's already smart. It doesn't need to go to a server to translate English to Kiswahili. It's like talking to you. You don't need to open a certain book for you to maybe check what the sentence means to this, to this. No, you already have that information. Maybe it can be in its very basic form, but then there is that question. You can ask a question like maybe just a greeting. How are you and habari yako? It doesn't really need to go to a certain server or do a lot of my own server to check the translations, because I don't really put translations in the AI of things like greetings. I accept it. I mean, I accept it to like already know that type of information, that type of translations, and all that type of stuff. Yeah.
Okay, but where does it get its information from, the data from? Does it bounce through different areas to come back and give you the information, or is the information on the platform itself?
On the platform, like now, for example, the platform that I'm trying to build.
Mm-hmm.
Okay, that is a very good question, because now it works in two ways. There is some questions that you might ask, and it doesn't really need to contact my application. The LLM itself can answer that. For example, if you ask a greeting, the LLM is pre-trained, it's smart by itself, meaning that it can already know what you are asking by just a greeting. But then maybe if you're asking about my company documents, maybe I'm building a chatbot for my own organization, right?
Mm-hmm.
If someone wants to know the policies, now the LLM or maybe the AI now has to go and fetch that information from my application now, maybe from my vector database or from my Postgres, wherever I've stored that information. Maybe check my rows and all that type of stuff to find that specific document, because now it's not trained on that data, but then it's trained for greetings. It can understand what you're actually saying. If you are greeting it, it can already understand without contacting my application.
Let me take you back.
Yeah.
Please explain to us what vector database is.
Vector database, it's more of storing numerical vectors. I don't know how to put this in a very simple way, but it's actually storing information in, let's say, semantic to enable semantic search,
Mm-hmm.
searching information in meaning rather than keywords. It stores information in terms of vector. I mean numerical vectors, which are just numbers. Or maybe should I use an example to
Yeah.
to maybe
Yeah,
say
maybe
it?
give us some
Yeah.
example. Yeah.
Okay. It works like this. Yeah. Um. Let's say you have a question. A user is trying to ask a question, like maybe let's say you've forgotten your password. Yeah, and you're trying to reset a password. Then you can ask the AI like how can I've forgotten my password, right? So meaning it has to give you the next steps, yeah.
Mm-hmm.
And the other person can ask something like I want to log into the system, but then I don't know my password. maybe something has happened, my email verification can't come that, meaning the next very step is what? To maybe press the forget password, all that type of process that comes in between forgetting a password. Yeah.
Mhm.
So this semantic, this information that you've stored is stored in numbers, which now it's searched for them in terms of closeness.
Mhm.
You know, the numerical vectors. Now maybe I've forgotten my password, and how do I reset my password comes to very very close vectors, and they relate. So
Mhm.
now it doesn't go through the whole document searching for forgotten my password. It might find something else, like if user has doesn't know their login details. Login details and forgetting my password are almost close vectors, meaning that now it has to come to a conclusion that it draws all the information that there is about forgetting password, and that then now gives you still in terms of vectors. Now that's where the LLM comes in, and then take all that in raw form, gives the user in a meaningful way that the user can now understand. So basically, a vector DB is a database that stores numerical vectors.
Okay.
That's the simplest way I can put it, I
Thank
guess.
you.
Yeah.
Thank you for explaining that to us.
Yeah.
So now let me take you back to the AI conversation.
Mhm.
Would you say that locally made AI platforms, or rather, are slower than more international ones, or are they relatively the same? Or does it depend on the kind of content that you're using it for?
So, for example, you're saying the platform that we make in Kenya, like the Sheria Africa platform, compared to a platform that is not locally made. Maybe it's made by a company in the US. That's
Yeah,
what you're
like
asking.
maybe like
Uh-huh.
ChatGPT versus Sheria Africa, or any other locally made in
Oh, so
Africa
so
platform.
which one is better? Or what's the question again?
Which one is better is a big argument, but
Uh-huh.
just which one is faster? Which one uses less? Takes less time to use.
I'll obviously say platforms like ChatGPT, because now you see you cannot compare the infrastructure that ChatGPT has and the infrastructure that us as a company, or maybe we're starting this platform, have. The type of resources that we get are very minimal compared to them. So for us, we have to use the available that we have, and these and the type of responses that AI can give, or the time that it really takes, comes down to the type of resources. So for example, if you have a very big server, your responses are generally going to be more faster compared to someone who is struggling in maybe a 2 RAM VPS.
Mhm.
So basically, it's about the infrastructure, and just to be honest, they have better infrastructure than us, meaning that we are expecting them to be faster than us. So we are going to be a lot on the optimizing side, trying to make them to be faster and all that, with all the few resources that we have. Yeah.
And when we look at Africa in general,
hmm
do you think that we can reach a point where we have the same infrastructure to be able to match or even to compete with platforms like ChatGPT?
yeah.
Or is that hard to say?
I don't know. Yeah, with proper investment, I think we can. With proper investment, I think we can. Companies maybe should try to. I don't know. It's really hard to get at that point. But then with proper investment, I think we can have that type of infrastructure even in Africa. Yeah.
Okay, that's good to hear.
Yeah.
So, what would you say is the difference between building an AI system for um, lawyers, let's say in Kenya, versus a more generic AI system, like one that just answers anything? What would you say are the differences that you've seen between the two of them?
Building an AI for lawyers, like you mean domain specific AIs and the general AIs.
Yeah.
Let's take this example, like maybe ChatGPT is the general AI, and then now we have our platform, right?
Yeah.
The thing with these large language models is that sometimes you may find that they know everything in general, but then know nothing in particular. Because for example, if you take a case right now to ChatGPT, right, and you ask about a law, maybe there's this versus this person, they're having this, it may invent theories
Okay.
in a very structured manner that you think is correct. All the citation, maybe you're asking about Kenyan law, right? It may give you even examples in terms of the Kenyan domain of law, like how people are doing the law, how you're supposed to say things and all that. But then it's just wrong, because the thing is, they may know about the Kenyan law, but then they may not have really read the Kenyan law or being trained on the Kenyan law. But then now making our own platforms, it means we're taking the model and then we're training it on our own data set. You understand? Like we'll take a data set that is only about the Kenyan law domain, yeah, and then now restrict the model through prompt engineering and maybe ask it to answer questions based on what we've given it only. So now, meaning that we're trying to be very, very specific. If you're going to cite, make sure you cite what we've given you in our data set. But then if you go to a general AI, it might just make up things and invent theories and do all that type of thing because it doesn't really have the data set for that. It might do some web scraping and do this and that, try to come up with a concrete answer because it can't really tell you it doesn't know. It has to give you something. But then ours, if it has to say something, then it has to be from our own data set and from our own examples that we're going from our own sources as reference points.
So these data sets that it takes the data from, are these data sets you've created or data sets that you've found somewhere and then uploaded to the site?
You know, that's actually the problem with a lot of these applications because now people are just trying to make applications with the data that they just go and find data somewhere and then you can put it. But then, you know, while making these artificial intelligence platforms, the thing that matters the most is the data. You need to have a very strong team that has to collect this data set. So for you to make a very good application, in our team at DataWise, we have a very good data collection team that came up with these. We collected several cases, put it in a data set, cleaned it, and everything. For example, our platform right now is running on almost 5,000 cases, which are well cited, the outcome, the judges, the everything well and properly researched. Mm-hmm. So data that you're going to put into this platform really matters because garbage in, garbage out. That's how it works even with the AI models.
And how do you deal with, let's say you get like case law or things like that. Have you ever encountered case law documents or any data sets that are poorly structured or maybe they're inconsistent or like they're just incomplete or something like that? Have you ever encountered that as you're building the data for the site? And if so, how do you deal with that situation?
Yeah, that happens, and it's exactly like what I've told you before. Is if you find a team that gives you an improperly configured data set or a data set that just looks the way it wants, then there's gonna be a lot of work there because now you have to start normalizing the data, trying to cut in rows, trying to find which one is working, which one is not. Because now for the AI, for example, like a platform like this that we're building, it really has to be accurate. It really has to be accurate. So giving us a data set that has some parts missing. For example, you're giving us a whole judgment, but then the outcome is missing. So I now have to sit down again and start writing scripts that maybe will remove all those sections or all those cases that are because now if I put this case the way it is, meaning that someone will ask about this case, right? But then we'll ask about the outcome. Now we have to say we don't know because remember we don't fabricate answers. We have to say we don't know, and that is like a very, very a big downgrade, saying that a certain chunk is missing, a certain piece of information is missing because the data that was collected wasn't really filled. So we now have to start normalizing the data. We have to removing rows and columns that maybe are missing data or not accurate and all that type of stuff. But then if you have a consistent data set, it's really a boost to these type of applications.
So you're saying if the data isn't right, you basically just have to go back and
Sorry,
redo.
what?
If the data isn't right, you basically just have to go back and redo the work.
Yeah, you really have to because you know the first step as an AI engineer when I'm given a data set to work with, I now have to review it first. I have to write scripts, maybe I can't read all of it. I have to write maybe Python script, maybe check all the columns and do this. And if there is a very big inconsistency, now I have to go back to the data team again and ask them because now maybe I'm not specialized in that sector. Now I have to work with them again. And this back and forth, it's really not good. It's really not good for this type of application because now any inconsistencies will drive wrong answers to this application. So it really has to be accurate. And when they give me something that is not accurate, or maybe I collect a data set somewhere, now I have to work on it myself to make it accurate and very, very consistent. Yeah.
Okay, so now let's say you have the data set and it's correct and it's accurate, everything is fine. Can you walk me through the process of how this data set goes onto the platform, onto the AI in such a way that the AI is able to retrieve the information from the data set and feed it to me as a user who's asking it questions? How does that process look like?
Okay, that's an interesting question and a bit technical question.
Where would you go?
Okay, so let me try to divide it into pieces. Let's say we can have maybe 6 steps from when I get the data set to when the answer comes to you. Okay, not 6 per se, let me say 4. Let me drop it down to 4. So, number one, we have to get that data set, and I said normalize it, check it for consistency, and all that type of stuff. It's called ingestion, whereby now I have to ingest this system and store it. You may get some like you might get a PDF that is very unstructured. That's where now we need a vector database. Even if it's structured, we can still pass it through the vector database. So first of all, is checking which dataset do I have. Is it a PDF? Is it an Excel? Is it this? If it's an Excel, well and good. Maybe we can even pass it to a Postgres database, because now we can have, for example, in this platform that I'm having, we can have 2 type of databases, which is the Postgres one, which now we can pass all the cases for to enable search and filter. Like if users can check edges, reduce year range, and then now we can maybe quickly give them depending on the Postgres data that we've stored. But then if it's now PDF like the Constitution of Kenya or maybe anything else, we now have to process number 2, we have now to split it into chunks, split it into pieces so that we can maybe pass it into an embedding model. An embedding model is something like maybe what can I say? We can use sentence transformer. That is there's this model or maybe something of from sentence transformers that can maybe take this embedding models, convert them into take this piece of chunks, take these chunks, then convert them into numerical vectors. You remember when I said about numerical
Yeah.
vectors? Now numerical vectors. Then now we have to store these into a vector database. Uh, Store them in more of numbers. That's what we mean, numerical vectors. So now, when you ask a question, now we already reached our knowledge base. We've already taken all the data that we have, and then we stored it in the knowledge. That is process number 2. Now, process number 3 comes with the retrieval. It's when a user asks a question. Now we need to go back to our vector database, check the numerical vectors and cosine closeness maybe. Then now we have to assess what this user is asking, because now it's numbers, right? We are looking for closeness. We are not really reading and looking for written text, like maybe what is my password. We're not looking for what is my password. No, we're now looking for vector closeness. Yeah, it's vector closeness. We're looking for vector closeness. And then now we find the answer, and then now we have to give it to the user. But then remember, these are numbers, right? These are just numerical vectors, right? We can't hand them to a user because obviously they won't understand. It's machine language, right? Now that's where the LLM comes in. That's where the model comes in. And then now it has to take that answer. That is now step number 4, right? It has to take that answer. And then now it has to convert it into a language that you understand. It's plain English, right? It gives you the answer in plain English. And then others can add, there are multiple other steps that you can add. Like maybe there's this concept of LLM as a judge, which means it now has to look at the answer. Because now from the vector database, we are handing it the prompt, and then we're handing it now the whole context, the whole answer. Now the LLM looks at this prompt of yours, look at these answers, and it says, you're asking this question, but then what we've retrieved is not really matching what the user is asking. So now maybe we need to bring it back, look for better answers. And then now the whole process comes back again like that, which now, if we go deeper into that, it now drives us to an agentic platform, which now is more of LLM checking and tool calling. Example, we're having multi agent platforms where maybe we can even have a supervisor LLM, which now it takes the prompts and then does all of the processes, calling other agents, this, checking the answer if it's correct, and then now we come to pass it the use. So simply, it's just those 4 processes whereby you take the document, no, try to normalize the document. Then number 2, you try to place it into chunks and then embed all those chunks into a vector database for numerical vector storage. And then after that, now it comes down to all the other flowing processes, which includes the retrieval and giving back to the LLM, and then now back to the user. Yeah.
Okay.
Yeah.
So the AI reads,
Uh-huh.
like when I ask it a question
Mhm.
and it goes to the AI, it reads this question in numbers.
It
Or have I said
okay,
something completely off?
the thing is, I'm not really going deep into the technical side, because now we're going to involve things like LangChain, which is now more of libraries that help us support this type of retrieval. So now it's like the operational brain of the whole process. Takes the question from the user, goes in the vector DB, and then hands it to the LLM. LLM converts it into words that you understand from your prompt, right? You're asking this, and then now we've given you these vectors. Now this LLM is smart enough to know that these are numbers, and now it can pass it to you obviously like that, yeah? So it gives you in a way that you understand. So it just takes it from the storage where it's given in numbers, then it gives it to you in a very simple. That's what happens when you ask these AI things like ChatGPT, or I don't know what platforms people are using, but then when you ask, that's the whole process. You ask it, goes to the vector DB and searches all that. That's the simplest form of a chatbot. That's how it works.
And this all happens within seconds.
Yeah, it happens within seconds. Yeah, with proper infrastructure. And there's this thing. For example, in our platform, we are trying to have this feature of research. A user might ask several questions that maybe they need research. Or let me give an example that everyone understands. When you go to ChatGPT, there's always a feature where you can just select you want research. You just don't want pure answers, yeah? So the amount of time that takes depends on the amount of tools that are going to be called and your infrastructure, of course. But then let's put that aside. Let's assume you're well off. Your company has provided you with proper infrastructure, right? Now it comes all to tool calls, all to tool calling and all that type of stuff, because now it has to provide you a concrete answer. Yeah, when you ask ChatGPT to do your research, it now takes time. You go to ChatGPT, ask a basic question today, and it just seconds the answer is there, right? But then if you go to research now, it will take time, because now it has to do all that type of research, call several agents maybe to handle this, to handle that, check on other websites what they're saying, scrape information from the internet, visit certain website. Now that's time is taking, because now it has to give you a proper researched answer, meaning it's going to take a lot of time to do that, because now there are several tools that has to be called. Whereas this has to be called, that one has to be called, this one, to form that one answer. Then all these answers come back, and then now there has to be some sort of LLM as a judge maybe to check this answer, check your question, does it match? If not, and this is an agentic platform, multi-agentic, it now goes back again, try to find what pieces are missing. Then now the whole cycle again, and until you have a proper answer, then now it hands it to you. So this process can go for a lot of times. If, for example, if it's an engineer who doesn't know, and maybe you're not setting the max retries, because it can continue to retry like that, maybe 10 times. So you can just set maybe a max of 2 or 3 tries for a concrete answer. So just make a certain tool calls here and there, scrape the web maybe, or do something you can use for maybe current information. Because now some questions you're asking to this AI, you find that I'm using a model, right? And then maybe it doesn't have a current information, because these models are pre-trained. So they're trained. For example, you ask a model maybe what happened yesterday. It can't know what happened yesterday, because it's not part of it, it's not part of its training, yeah? So now it has to maybe call a certain tool. Maybe Tavili enables this type of research and this type of getting information or current information. So maybe that tool can fail, and maybe it now has to try for several times so that it can get to it and then come back with an answer. So all this type of process is what maybe can determine the type of time that it's going to take for this LLM or for this application of viewers to return an answer back to the user. Yeah.
So what's the difference between the research feature
Mm-hmm.
and just using it generically, is it that the research feature goes outside of the platform to look for answers,
Mm-hmm.
and then the other, like normal AI, just gets answers within what you've uploaded, like the data set that you've uploaded? Is that the difference between the two, or what exactly sets them apart?
Now, you see, in some platforms, really depends with the platform. Because now in my platform, like the one I'm building, I can't really direct the application or the LLM to go outside because it may go and fabricate answers.
Mm.
It can go to a certain platform and then get the wrong information from it because maybe that platform they are posting the wrong information and then comes back to me. But then now we are having maybe your application is focusing on maybe trending news and blogs and all that. So it's allowed to go outside and do that type of research. So what takes time is really going outside there and then now trying to form a concrete answers, trying to pull several sources, because now your answer might need, because even now if you go and ask Google, or maybe you go and ask any AI, maybe cloud, you can see sometimes it gives you links. It means that it has visited that link, gone to that site, get the information for you, and then compile it for you so that you can have a concrete answer. So this all tool calling and this all going outside, scraping and all that, that's what takes time. Yeah.
Okay. So I want to now focus specifically on this platform
Mm-hmm.
that you're building, Sheria Africa, and
Yeah.
I'll put a link down
Mm-hmm.
in the description for those of you who want to check it out.
Great.
On the website, you mentioned that your working method is research, reason, and verify. So, how do you design a system that can think like a lawyer, that can research, that can reason, and that can verify in an accurate way? Because, like you said, it needs to be a very accurate sort of platform because people are using this, like, to do their legal research. So, how do you create a platform that can think critically about these legal aspects of, Kenya's legal landscape? How do you do that and make sure that
So,
it's accurate?
mhm. Yeah, that's a good question, and it all draws down to this the multi-agentic type of applications. So users can ask questions, but then now we don't want to just give them a short answer or maybe a brief answer. We want it to cite, we want it to use examples, we want it to explain to the users. So we are having our own data set, right? So we need the application as the first step to check the question of the user. Maybe sometimes it's just a greeting. You don't need to do any research or even look our database for that. So just answer that question. But then the user asks us about a certain case that happened. Tell me about a case between this person and this person. Who was the judge? What happened in this? What are the takeaways of this? What does the constitution say about this? You see, now those are several questions bundled together.
Mhm.
And now we can have our agents tackle it one by one. We can have one of our agents do the database checks. So we can have one of our tool maybe called the Postgres and check that case, bring that information back, and then now we have the LLM trying to collect all that information from all those sources that we're trying to call in our application, and then now we want it to compile that answer into a well and a very detailed answer for the user. So take this part, see this part, which one relates, and then now after that, the part of reasoning, we can have another LLM, a very separate one. This one doesn't go and research your answers. What it does, it checks your answers, right? So it takes the answers from those it takes the answer from the other agents, right? And then now it takes it and reviews it. Takes your prompt, maybe does triage, splits the answer into several sections. Then now it tries to see if any question is skipped, if any question has been, if the sources have been cited, because now we want to cite in everything we do. This is a law platform. We just can't give answers randomly like that. We have to cite. So check the citations, verify the answers. Does it match what the user has really given as the answers and all that? So after all that has happened, then now we can have a concrete answer. Yeah.
So you have multiple agents that are answering this one question, or these
Yeah,
multiple
that
questions.
is basically it. Yeah, that is basically it. You can have multiple uh agents or multiple tools that are working together to give you an answer. It's like what I told you. You can have a supervisor that takes a question. Let me give you an example. Um, we can have maybe an application, maybe an e-commerce application, right? And then now the user has to ask something like where is my order at, maybe. And then now this is an agentic application with several agents, right? So multi-agent application, and the user asks a question: when does it arrive? So now we can have our agent that has the calendar, that checks the calendar. We can have our agent that maybe goes to the database and checks when the user booked that order, and then now it can even call the database and then check where the location of this order is at. So we can have a tracking agent, and then we can have a calendar agent. So now it checks the database and then sees, oh, the package is maybe at some place, the warehouse right now is being packed, right? So that is answer number one. But then we need the calendar. The user asked, when does the package arrive, right? So we need to tell them it arrives on Sunday. But then now we have to look which date is today. So we have to go and go to the database, go to that agent again, look at the calendar. Today is Monday. It arrives on maybe Wednesday. So maybe we put 2 days. So your package is at the warehouse right now, is being packed, and then now the other agent comes and says it arrives on 2 days because I checked the calendar, right? So now it formulates this answer into one answer, right? Then now we're having the LLM as a judge, the final throughput, yeah. So it comes in, and then now it has to make this answer as one, because this one has given its answer, this one has given its answer, right? So compile this answer into one, see if it really answers the question the user has asked, and then now pass it back to the user.
Is it possible to just have one agent do all of that?
Yeah, it's very possible. It's very possible. For example, in small applications, it's very possible to have just one agent do all the. It can have several tools to call, but then they are not really maybe LLMs and all that. So you can have maybe a one graph, end to start, calling one agent that does all the research work for you, or maybe does all the things for you, and then compiles it. When we say we are having a multiple agent step or that sort of thing, it's maybe a complex application that maybe has to have a lot of stages. Sometimes it needs even human interference. You mean human in the loop. It may even ask you questions as a user. Maybe I don't know this and that and that. So for those type of complex application, we might need a multiple agent system. Yeah, but then for maybe a simple thing like that e-commerce, maybe you can have the same agent do that because it doesn't really take a lot of time. Just go there, check this, go there, then compile this, and then give the answer back to the user. Yeah, it's very possible to have one agent.
Okay.
Yeah.
So thank you. We've had a lot of information about how the platform works and the platform itself.
Yeah.
And I want us to start coming to a close. So I want to ask you if, when I'm looking at Africa as a whole now, not just in terms of the platform itself, but like if we want to build AI systems that serve us in the same way that Sheria Africa is serving lawyers in Kenya, what is it that we need to do differently? Because I know, now a lot of us, even within Africa, we use ChatGPT, we use Claude AI, Gemini, everything like that. But if we want to build systems that are for Africa, that serve Africa, all that kind of stuff, what do we need to do differently as a continent, as companies within the continent? What needs to change, or what do we need to have for us to be able to do that, so that we can stop relying on, the ChatGPTs and whatnot?
I wish maybe if even the government could ask me something like that, because now we'll create impact, right? We'll create impact. But then it all goes to these two things that maybe I must say. And one is maybe infrastructure. Maybe try to make things cheap for us, or maybe have local companies that are providing things that we need at affordable prices and all that. Making this type of application, they take a lot of resources. And resources is a bit of a constraint to a lot of companies, and they have to really budget before they come up with the application or even the idea at times. And then the other thing is maybe our data. All the companies or people collecting data, they really need to make that data, maybe collect clean and insightful data. Yeah, because now if we feed these random data sets to our models, we're going to just be getting to get random answers as always. And also for Africa, if you're maybe training this application, for example, now in our platform Sharia Africa, we are trying to achieve to also get to the general public, meaning we have to tune this model to even understand our local languages, because some person maybe they don't really speak Swahili properly, or maybe English, and then they want to know their rights, because they're also trying to cover that gap. Because technically in Kenya, as we say, the constitution is really public, but then is it really accessible to everyone? Does everyone know it even exists? So for a normal person, for a normal mwananchi in Kenya, we are trying to make this platform accessible to them, to know their rights and all that, the procedures, all that type of information that they want to access. So if you're making these systems, maybe we can have organization that collect data set in our local dialects, like they collect the information. What does Jaluo say in this? What Kikuyu says in this? What other languages, and maybe even general Kiswahili, because now we're having platforms out here, and we're saying these platforms are built for the people in Kenya, but then they only talk English. Are they really for us? Does the general public even understand what? Because now, if you ask a question, it drafts it in the Kenyan constitution form, all that. Well, it's a lot of complication for someone local to understand. So maybe we should collect our local data sets too. Maybe we should train these models in our own languages too, so that they can really help. Because if help is what we want to achieve, then maybe we should look into that. Yeah.
So we also have to do our part to be able to.
We really have to. In fact, we are very behind. We really have to. Yeah. we really have
We need to catch up. We need to
catch up and as fast as possible. Yeah.
Yeah. Thank you for bringing that up, because actually on the African Stack website, we have an article coming out on languages, AI languages, and adopting African languages. So you guys, our listeners, can also check that out on our website. But Mohammad, thank you so much for joining us today. For anyone who wants to check out the Sheria Africa platform, the link will be in the bio below. But you've been listening to the African Stack, powered by DataWise Africa. Thank you for tuning in, and see you next time.